Hello and welcome to another CADimensions Smarter Engineering podcast. My name is Derek Welker and I'm joined here today with Brian Danson, who's on our technical side. Today we're going to be talking about hardware, right? It's a question that we get a lot. Well, more you get a lot because you're better with hardware than I am.
Yep, all the time on tech support.
All the time. So SolidWorks just recently updated their minimum requirements for SolidWorks. They went from like 8 gigs of RAM to 16 gigs of RAM. So, when you get that question a lot, what's the first thing when someone comes to you and says, all right, what computer or what spec should I have for SolidWorks? I know it's kind of a loaded question, but where do you go?
It's definitely a loaded question. At this point, with what SolidWorks has on their website, I definitely do think it was time to upgrade those stats that they had up there.
They were definitely outdated.
They were a bit outdated. So so they've upgraded recommended processor speeds and the RAM requirements as well.
So Brian, with the RAM, they went from 8 gigs to 16, and the processor, I thought it was like 2.7, and we're now at 3.3, right? So we were always recommended in the past that we would say, even though it said 8 gigabytes of RAM, we would say if you're buying a machine, go with 16. Is it still the case? Are we still saying 16 is good enough for now, or should we kind of future-proof it a little bit and go to 32?
Well, a lot of times when we get asked these questions too, the first follow-up before we even make any recommendations is, what are you doing with the software? Depending on what environment you're in and what you're requiring your SolidWorks environment to do for you is really how we have to handle these things. So 16 gigabytes of RAM, in most cases, it's going to be plenty. In most cases, but again, there's certain cases when you're getting into high-level simulations or very large assembly modelings where going above and beyond those minimum requirements are going to do a lot of good for you.
Yeah. Right. So we always say that we kind of break down the computer specs into a number of different categories based on what they require. So with Visualize, it obviously requires more graphics than computer. So we're going to say Visualize is in its own category. We'll say SolidWorks and simulation are in their own category, and then we'll say kind of flows in its own category as well.
Yep.
Right?
Yeah, I would agree with those.
So we're breaking those down into 3 categories, but we'll explain as we go through all of the different hardware that's required for each of these, why we break those down into each of those categories. So first, let's talk about processor speed.
Okay.
Right. So it was 2.7. We're up to 3.3. Are we? The dual cores are kind of faded out, and everything's really quad core now.
Yeah, at least quad core.
At least quad core. Yeah. But does it make sense to go with 8 cores or more? I mean, we know that SolidWorks only runs on a single core. It's only a single processor. So do we go with 8 or?
Again, it depends what you're doing with the software. I would say that your CPU is going to be one of your most utilized components in almost any, except for Visualize, any version of the software that you're working with. And that being said, SolidWorks is mostly single core processing. So however fast one single core of your processor can run is what's going to determine most of your performance in there. So if you have a CPU that has 8, 12, 16 cores with a low clock speed, you're going to get less performance out of that than a CPU that has 4 cores with a much higher clock speed. And that's in base SolidWorks. So pretty much every single computation inside base SolidWorks is running off of one single core.
Okay. So since we broke those out into categories, right, the reason why we put simulation and SolidWorks together was because the simulation can only use a single core as well. Except we know that if you're using curvature-based meshing, and some of the studies can be run using multiple cores.
Right.
So that's why we kind of grouped simulation and SolidWorks together. So there's some studies that are limited to single core. So like drop testing would be one of them. But if you are using curvature-based meshing and then the solver type of like direct sparse, you can get into multi-core processing.
Yeah, that's definitely correct. But what we have found out with the simulation, base simulation within SolidWorks is that it can utilize some multi-core processing, but there's always a point of diminishing return. And from what we've tested and what we've found in research is that diminishing return is somewhere between 2 and 8 cores, where you're really not going to get any more performance out of having more cores than that. And nowadays, with these new processors that are coming out from Intel and AMD, you're getting these new processors with a minimum of 6 to 8 cores. So choosing more cores going for the simulation environment and skipping out on that clock speed is, again, it's not going to benefit you as much as you would think. So that's why we group those two together. When you're thinking base SolidWorks and most simulation environments, the higher the clock speed CPU you can get, the most you're going to get out of that performance, yes.
Absolutely. That's great. And, you know, a lot of these machines now are getting up in the 4 gigahertz range of processor speed. So we're seeing some really, really fast computers these days, 4, even in 5.
Into 5, yeah. A lot of the newest Intel releases have out-of-the-box boost clock speeds up to about 5 gigahertz, which is quite quick.
That is very quick. All right, so let's move over into RAM, right? We talked about 16 gigs of RAM being okay, but SolidWorks added something on their minimum specs called ECC Ram recommended. Yeah. What exactly is ECC? I don't want to go into the full definition of it and get into exactly what it does, but is it something that we recommend for SolidWorks, or what do you think?
Again, it really depends on your environment. So without getting too much into it, because we could talk about it all day, it just stands for error correcting and checking, which means that built into the RAM, it's constantly acting more stable than regular RAM is. So as it's storing all that temporary information in the RAM while you're doing your work, while you're designing, running your studies, it is constantly sort of backing up and making sure that if there's any loss of data, it knows how to get that back and keeping everything contained for you and a little bit safer. In most scenarios, it would be recommended, but in most scenarios, it's not something that is required. And a lot of the reason for that is it's expensive. It requires very specific motherboards, and it's usually only compatible with Intel Xeon processors, which, based on what we've discussed so far, goes against what we were just saying about choosing a CPU, because the Xeon processors are geared toward very high core count, less on that base clock speed.
Gotcha. So we're saying that ECC RAM is a great idea in theory and great for SolidWorks, but then when you put it together with the actual hardware, it doesn't necessarily pan out well with SolidWorks because of that high core count.
Right. Okay. You would have to compromise your other hardware choices in order to get it.
Right. Yeah. So, and we're saying, you know, it's all of this error correcting and checking. It's probably only necessary if you're really taxing the machine with some pretty hard, you know, computations, really.
Right. Very, very high levels of multitasking, very, I would guess, scenarios where you're using as much of the system resources as possible constantly, where you might run into some sort of critical failure for running out of resources. That's where ECC is going to possibly help you in the long run. But again, most users really don't get into that level of requirement for their machines.
Yeah. So what we're saying is, kind of a loose recommendation would be skip out on the ECC RAM and put that money towards a better processor.
Right. ECC RAM also was designed for server environments. Okay. So it's for machines that are running consistently, constantly, all the time, backing up tons of data.
Okay. That's great information right there. All right, now let's move over into one of my favorite topics here is graphics cards. Ooh, yeah. This is what I find the most interesting because I am a Visualize person. I love Visualize. So when it comes to Visualize, the power that's inside of the graphics card is called CUDA cores. So Visualize uses the CUDA core technology, and that was actually developed by NVIDIA. So the NVIDIA graphics cards certainly work better for Visualize because it uses the technology that's inside of their graphics cards. So if you're looking at going with Visualize, your best bet is to get some sort of NVIDIA card because of those CUDA cores. Yep. So when we're talking about CUDA cores, right, when we talk about processors, we're talking like 4 to 10 cores. When we're talking about CUDA cores, we're talking upwards of 1,200, 2,000, 3,000 cores.
In the thousands of range,
In the thousands. So just so you get an idea of where those CUDA core, the number ranges from, right? So
and that could be per video card. There's no, you don't have to hold yourself back. You can double up on video cards, which is what a lot of people that do rendering softwares do.
Right. So, we actually just found SolidWorks put out a nice graphical chart, and we'll put it in the video here, is that if you double up on graphics cards, you can essentially save a significant amount of money than just spending extra money on a better graphics card. So we're taking a look at the new RTX 4000 card. You want to talk about that?
Yeah, so NVIDIA just released, I want to say back in November, a new lineup of their graphics cards for both GeForce, which is their gaming line, and Quadro, which is their workstation line. And the Quadro RTX cards are extremely powerful, and the base version is actually the cheapest one that they made is the RTX 4000. And when compared to, let's say, a P4000, which are the Quadro cards that we've been familiar with for the past couple years for workstations, it is more than twice as capable, has more than twice the processing power. And you'll see in the chart that we put up there, a P4000 versus the new RTX 4000 gets rendering speeds of about half.
That's crazy.
The lower the number, the better in Visualize.
Yeah, I think I have a P3000 in my laptop, and I thought that it was screaming. Well, this new RTX 4000 card has to be insanely fast. But the point we're trying to make here is that the RTX 4000 card's roughly $900.
It's about $900, yep.
Right. So then the next step up from that for NVIDIA is the RTX 6000 card.
Yes.
And that's how much?
I think if you get it on sale with a couple mail-in rebates, it'd be about $4,000.
$4,000.
Yeah.
$4,000.
Just about.
But so the point that we're making here is that in Visualize, if you double up your cards, you can essentially double your performance. So if you take two RTX 4000 cards, slap them in a machine, you'll actually get better performance than if you were to just spend the money on buying that RTX 6000 card, and you basically save $2,000.
Right.
A little bit more than $2,000. So if you take a look at the number of cores between both of those, so if you take two RTX 4000 cards and the one RTX 6000, the two RTX 4000 cards actually have less CUDA cores than the RTX 6000, but somehow in our chart, it performs better.
Right, and I believe what that has to do with is when you take two graphics cards like that, again, with Visualize, we're solely looking at CUDA cores for the most part. So we take the amount of CUDA cores in each card and combine them. But there's also other resources attached to these cards. There's onboard memory. So each RTX 4000 would have 8 gigs of memory on it, which by then gets doubled as well. And there's actually also other cores inside these cards. The RTX ones have what's called tensor cores, I believe,
okay,
and ray tracing cores, which Visualize works on ray tracing, right? So
okay,
that's how it gives you your photorealistic rendering. So all those resources get doubled as well. So yeah, it's definitely something not to overlook if you're looking at building a very powerful rendering workstation. It could benefit you to look at what sort of resources having two graphics cards could provide rather than one much more expensive graphics card, for sure.
Yeah, and the fact that you can save money, and just if you go with two graphics cards, you essentially get double their performance. That's awesome.
You can do more than two graphics cards as well, but with Visualize, when you get to two graphics cards, they scale pretty much evenly, so it sort of doubles your capacity. As you start adding more, I believe Visualize supports up to 8 graphics cards that you can run in line, and after you get past 2, it doesn't scale 1-to-1 anymore at that point. It slowly drops off as far as efficiency there, but you can definitely rig together quite a powerful machine.
Yeah, I think at this point, we would just recommend using 2 cores at your maximum because you get that double performance for your money. Right. And then after that, too, it's kind of a point of diminishing returns. But still, using 2, I don't want to call them bottom-of-the-line graphics cards because those RTX 4000 cards are insane.
Very good.
But 2 well-priced cards will beat out a significantly more expensive card. So that's kind of a CADimensions tip for all of you guys down at home.
Research. Check. People are YouTube and Google. People are always taking these new technologies and testing them and benchmarking them and seeing what they can actually provide. And not always the most expensive thing on the market is going to work for your applications, especially when it comes to CAD design.
Awesome. Yeah. So also, gone is away the spindle drive of hardwares, and we're now moving into SSDs. So I don't know much about hard drives other than I look at how big they are. but there's a lot more information on that. Can you make any recommendations for hard drives other than obviously SSD?
Everybody should have an SSD in their computer.
I feel like that's pretty obvious.
The first
at this point.
time I bought an SSD, I was actually very surprised by the performance increase. I knew based on the specs that it would be faster, but it was definitely much faster. But in the realm of just SSDs, now there are multiple different kinds. There's, we call them the 2.5-inch SATA SSDs, which is what probably everybody pictures for an SSD. It looks it's 2.5 inches or so and plugs into the back of your computer. But they have ones now that are plugging directly into your motherboard. They're called M.2 or NVMe hard drives. And essentially what they're doing, since they plug directly into the motherboard, is they're taking the bottleneck out of transferring that data across wires and cords. And they're very, very fast.
Okay, that's I didn't even know that technology existed. You said a whole bunch of mumbo jumbo over there. I'll just make sure that they got it. But yeah, no, that's really good information. There are a couple things that I think we missed as we were going through. Was that when we're talking about processors, we said probably just that quad core is going to be pretty good, or anything between 4 and 8 cores. Mm-hmm. In SolidWorks simulation and even Visualize. Visualize a little bit out there, but SolidWorks and simulation really just use a single core. But with Flow, we can use much more than that.
Yep, Flow's the outlier. Flow is doing flow simulations, and I believe even plastics we were looking at. Mm-hmm. That part of the software does have the ability to really capitalize on multiple cores, and I haven't found many good exact documentations on it, but pretty much the more the merrier on the cores. It allows you to take your meshing and your solving of your simulations and break them down into smaller components and solve them in separate places, which is what those cores would be good for.
Right.
Whereas, unfortunately, the other packages of simulation don't do. So if you're doing very heavy flow analysis and you're doing that all the time and you want to look into those processors that have more cores, which usually direct relationship, more cores usually means more expensive. You could definitely benefit from those in that environment, for sure.
Gotcha. But if you're only doing flow maybe once a month or a couple times a month, you're probably better off to stick with anything between 4 and 8 and kind of be good with that.
Right. Yeah. Definitely take the info of what you need the software to do. Pretty much everything that we've discussed so far hasn't been a real hard line of you must have this to run SolidWorks, to run simulation. If you're looking to get your peak performance out of them because you're doing that all the time, and obviously time is money, those are the types of hardware components you would want to consider. And that even being said, we focus a lot on graphics cards with Visualize. Visualize does have 3 rendering settings to it. Mm-hmm. You can render strictly with a CPU. So if your CPU happens to be much faster than your graphics card, you can still use Visualize as efficiently as you can. Then you can render just with your GPU, if your GPU happens to be way better, or you can combine the two. If you don't have stellar of either pieces of hardware, you can combine their resources and still use the software for sure. That's
a great point, and we definitely missed out on that. But the benefit with using hybrid mode in Visualize is the fact that you can use both. But do note that there is a limitation with it. So if you do have 2 graphics cards that are super fast but not a really good processor, and you put it on hybrid mode to use both of them, the limitation is it will only go as fast as the slowest component. So if you have a slow processor, it's going to be pegged at that. If you leave it in automatic mode, Visualize does a good job at understanding what you have, and it will probably just pick GPU, but you can obviously specify what you want, It's kind of a hard stop.
Yep.
Yeah. So some other things, or there's other ways that SolidWorks tests its information, and that's through the SolidWorks benchmark. So do you want to talk about that a little bit?
Sure. So there is a benchmarking sort of program that's built into the SolidWorks RX tool. It's one of the last tabs in the RX tool, and what it allows you to do is it really allows you to stress test your computer and see. It will go through and it will run SolidWorks, and it will check for open times, so how long it takes your machine to open and close and save files. It will test your CPU, it will stress test your graphics, and it will really just put it to the test and give you an overall score for it. And on the SolidWorks website, the benchmarking results website, you can compare your scores to other machines that are out there. It is important to note, if you're going to compare your scores, I'd recommend comparing them by the sort of software that you have or the hardware that you have. So if you know what kind of CPU you have, search the results for other people that benchmarked with that CPU, and you're going to get a better idea of where you stand. Because if you just look at what's number one on that benchmarking thing, you'll feel like your computer is quite inadequate.
Yeah, and it's also, I feel like it's a good way to kind of gauge the performance of some of these things as well.
Yeah,
right.
And it breaks it down too. It can let you know if you're not experiencing good performance with SolidWorks or what you're looking to do with it. It'll let you know where your bottleneck is, because your CPU gets its own score, your graphics card gets its own score, and then your I/O, or so your input and output device, which is your hard drive, will get its own score. And whichever has the highest number, you can see that's where your bottleneck's coming from.
Yeah, and then another good thing with that is like you can actually test the machine that you have currently, and then take a look at what machine you might be getting, so that you can verify that your score, number one, is going to be better, but then also how quick it's going to be as well.
Right. There's thousands of benchmarks up there on the website, and it's very thorough. So if you have an idea for a computer, if you take our recommendations on looking at new computer hardware for what you need to do in SolidWorks, go on the results page and search those components that you're looking at and see what sort of scores they got.
Absolutely. And the other thing is, obviously reach out to us. Brian loves talking about computer specs.
I could do it all day.
So, call us if you have any specific questions. Say, this is exactly what we're doing. So, what do we need? What are the best recommendations? The other thing is, if you're looking for us to help you spec a machine, we do offer box machines that do come preloaded with the software as well. So we can help spec out some box machines for you. And we do actually have our own benchmarks that we've run in-house on those box machines, so that we can kind of verify what it is on those actual machines comparative to what you guys currently have. So is that it for today, Brian?
I think we summed it up. We covered a lot. I feel like some people might have fallen asleep at about the 10-minute mark, but if you haven't and you found this useful, or you want more information, like Derek said, please reach out. I'd be happy to talk to anyone about it.
All right. Well, thanks everyone for tuning in for this podcast. Hope you see you on the next one.